Alright, draft physics video. Kind of a, I don't know, maybe no point kind of video, but I thought I would respond to some of these other theories out there a little bit, at least in the sense of David D. Hilster, his father, have the particle model, and he's talking to this guy about another ether model, and it has this infinity catch in it, and I just thought that was worth a little bit of that's going to require an awful lot of you got to come up with a lot of physics to explain the existence of an infinite anything all the way down, and to do it in any kind of rational sense. So I'd say right off the top, the de Hilster particle theory has some idea of the particles we're familiar with going the speed of light, the photons, and they're called G1s, but they're the same as electrons somehow, even though electrons don't move the same speed. So I guess we don't have to worry about the speed of something isn't a constant, which is messy. And then he has this underlying particle, another force, let's call it, or whatever, that is moving the photons, so to speak, pushing them. These littler particles are pushing the photons, kind of thing. I'd say a huge difference between like my particle model, their particle model, would be they have the idea of a photon is really a whole stream of particles. Like one photon is a whole bunch of these little things. And then I guess when you have a whole bunch more of them, it's an electron. But again, no explanation for why the speed difference between these things that are supposed to be made out of the same thing. So there's not much continuity just on the surface. And they somehow are obnoxious to the idea of charge being a concept they need to explain, which to me is really bizarre, since the Bob guy was an electrician. And just seems like it's right in your face that you have to explain a polarity difference, a fundamental difference in some way. And I found it kind of easy to just kind of trip over the idea of it, in the sense of just recognizing that just like in the case of the two-slit experiment, where they've assumed that the photons are doing all of the tricky stuff, and that it's not some bigger thing that's influencing that behavior, that the tricky part is not in the photons but in the material that the photons are moving close to, and that the big things are telling the little things where to go. You could sort of make the same argument about magnetism and electricity, in the sense that they always keep talking about the electrons, and they kind of ignore the stuff that's moving the electrons, and they just call them virtual photons or some other thing, and just kind of pretend it's not significant. And the whole idea of charge isn't really explained as something intrinsic in the electron and the proton, rather than thinking that maybe the charge is the fact that the forces see the electrons and protons as different things. I think they're factually different, but I just mean it's the field energy that's providing the capacity for there to be a difference, in the sense that you just have to make the field energy polarized. And then that creates the polarization of the electron and the proton. It wouldn't have any polarization if there wasn't already polarization in the field energy itself. That kind of thing. So anyway, so both these guys believe in infinity. This guy is supposed to be the infinity guru or whatever, all this guru stuff, which isn't a very nice term in my opinion for doing science. I mean, gurus are for mysticism and medicine men, and it's kind of, to me, it's not a attractive kind of word. It's not the kind of thing I would call somebody as a compliment. It's kind of a term of the propagandist or the manipulator, in my opinion. That's the taint it has, the show mysticism of especially like India. It's all kind of gimmicks, walking on the hot coals and the needle bed, and they're all tricks. It's not snake charming. It's all bullshit. Anyway, so it's ether against particles, but the particle theory isn't a good replacement, and of course I don't think ether it's way too sloppy, in my opinion, infrastructure to just say the word ether and say, there, you've done your job, because the nuances of the forces they're real. They really exist. The forces act fundamentally, not fundamentally differently. They're fundamentally the same, in the sense they all go the speed of light. Magnetism, gravity, the nuclear forces, it's all the same speed thing for the force carrier. So all the forces are moving the same speed, so they have something fundamental in common, but they clearly manifest, really differently. And you have to account for that difference, and I don't think any of these theories do that with any detail. And again, annihilating charge just seems to me a huge... You can't even start from there. You have no hope. Charge is so fundamental to how everything behaves. You just can't do that. It's like, that can't possibly work. Would be my advice to somebody thinking they're going to do without a charge in the universe, explaining it. And you're not going to explain it without creating a mechanism that is going to essentially be black-white. There has to be a difference somewhere. You can't just say G1 particles, there, I've done my job. That's not going to explain charge. Alright, anyway. So I really want to get to the infinity part, but I'm just trying to do it in some sort of graceful manner. And I didn't test the audio before I hit the button, which is a real mistake on my part. Just because I'm not sure the audio will be correct on this video. But anyway, we're going to go for it anyway, because I'm not redoing it. Yeah. So I'll take a look and see if the audio is coming through on
contradictions
this.
galore, and so that was what the whole point of it was. And of course, you can read the blurb on it if you go to...
So he's talking about his book. Okay, so I guess we don't need to hear this part, but he wrote a little thing for his book, blah blah blah. So let's go a little further here and get to some details, maybe.
To infinite universe theory, which says that the universe always existed and existed everywhere. There's no place for anything else, and so that...
Alright, so this sort of gets to this creationism kind of arguments and all that kind of stuff, and I just don't see any point in it. So there's probably lots of thought experiments and intelligent ways to dissect this idea of infinity and why it has problems. I would just go by the physics, and we just take some of the physics we know. I guess some of the arguments that occur to me. And the big argument that occurs to me, well, first in the Hilster. Sorry about that. I don't know why it's past traumas with a Hissner. Anyway, Hilster was the idea that their G2 particles, the ones that are moving light, would go c squared in speed, which is a ludicrous speed anyway. I mean, it's just, you could say like twice the speed of light. That might be reasonable, but the speed of light times the speed of light fast, I mean, you might as well just say instantaneous. That's such a fast speed. And I would argue that you can't make the littler bits go faster, because then you lose all your fractalness. The smaller your universe going down, it has to move much slower. The universe going up is the one that needs to go faster because of the distant thing. So you can't make stuff on the small level going faster than the speed of light, because that ends up being ludicrous speed on our level, and then you have instantaneous action. And we'd see that somewhere in the real science. I mean, obviously in quite bizarre experiments they can come up with some notion that they've entangled a couple of particles, but we don't see it anywhere in the universe that anything happens at a distance. Spooky action at a distance still remains spooky action at a distance. It's not some kind of common feature of the universe. or we would have noticed. So right there, that doesn't work. And so I would argue that yes, on the universe is one universe, and so this idea of saying, okay, well, let's go a billion times smaller, and let's go a billion times smaller, and we'll create some new platform in which the universe functions entirely differently, I mean, are entirely the same, are very similar or something, some kind of fractal of the bigger universe. I just don't think you can do that rationally, because I think the universe is just one universe. The empty space between us and the moon is the same as the empty space between electrons and protons. That space is exactly the same space, and the forces are exactly the same force. So obviously the speed of light from an electron's perspective is it's a different it's a different world they're living in than the world we're living in, but it's the same mechanism. A photon is still moving the speed of light between an electron and an electron, and between the Earth and the moon. And so in a sense I would argue that those forces from like an electron's perspective would be like us seeing a baseball, or like the Earth being maybe even hit by something the size of a quarter of the moon. Say if the Earth was going to be metaphored as an electron, you know, the forces would end up being rather huge, giant things that we would see in the universe. They'd be like baseballs flying between the Earth and the moon, and basketballs flying between the sun and the Earth, or something. They'd be the forces would be huge by comparison to the objects in the universe, and yet we know, I think, that the forces are exactly the same. I mean, the photons that are, hitting you from the screen you're looking at, those are the same photons that hit electrons, and the same photons that hit protons, and it's the same things interacting with the atom. And so there's no fractaling here. They're real things of real size that don't shrink or grow depending on what world you put them in. It's one world, one universe. And so this idea of something all the way down, I think, is not viable. Now, why do people seem to reach for that? I think it's just that notion in the head that something had to make it, something had to cause the universe. Like, what kind of something? So I mean, my first argument against that is, I don't want to get into theology questions, but my first, or even biology, is evolution. We know where we came from. We evolved from green slime and shit. There's nothing romantic about our creation. There was no God that poofed us into existence. There was no God that poofed the universe into existence. So you're always stuck with a first cause problem, no matter what theory you use. The fact is, the universe got created. The stuff in it happened. And whether it happened in a permanent way, like it happened once, and there's only so much of it, and it just does its thing, it contracts and expands or something, who knows. I'd argue that's viable, but who knows? And who would even bother going there? I guess part of me says, if you think physics is supposed to explain the creation, then I guess you don't understand, the limitations of physics, because physics can tell you about why there's ocean waves and why there's beach sand, but it can't tell you how the sand, what exact, planet or what sun exploded and created the atoms in it. It can't do that. Can't go far. It can only go so far, and that's it. And then it can't know anymore because the trail is gone. And so I don't think you're going to find the trail to creation. Especially from this idea of nothing creating something. The fact that there's something sort of means that there's something. So obviously, and it just depends on what kind of form the something is in. Some sort of inert form, little ball, or some, universe expanded and all that kind of crap. But I'm certainly not glued to any kind of notion of a the traditional Big Bang theory. I think there's lots of other explanations for the cosmic background radiation. I think there's other explanations for redshift. You don't have to imagine the universe as, frankly, it just doesn't look like it. If it was an explosion, we should be able to see the parts that are moving faster than the other parts. The explosions always have some sort of different stuff going on, and you should be able to see that technically, unless we're just a tiny, tiny, tiny piece of the real universe. Which I don't really want to do. That probably takes a whole nother pile of thinking to figure out what the consequences of that would be. But the whole explanation of a universe that came from some sort of energy that expanded, there's still no explanation for how the energy condensated into, how do photons combine to create matter and all that kind of stuff. So there's no explanations for any of that kind of stuff. So I would tend to think the matter was always something. But whatever, doesn't. I'm just trying to get to the point that they want to go there because it's sort of, they want to try to make it circular. They want to try to make it all tie together, and I don't think you can do that with the universe. It just does shit, and there's some explanation. There's some reason, and it all, like I said, it could just be error code. The universe is just laying nothing everywhere. Just no, there's some more nothing, 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 nothing. Something breaks, and oops, I made a mistake. I made a something. The universe is as flawed as we are in that sense. It's the mechanics is broken, and that's why there's a something instead of a nothing, something like that. But whatever the answer is, it's not going to be some answer that's going to be gratifying in any human sense. It's going to be some mechanical answer, and it's not going to lead to the snake eating its tail, because that shit doesn't happen in reality. Snakes can't do that. It doesn't work. It's unsustainable. So you're not going to find your circular truth. So anyway, yeah, I just don't see any point in it, and to pretend that it doesn't have a ton of mechanical problems, in terms of, if you make it go all the way down in some sort of structural mechanism, then yeah, you have to create all kinds of time restraints and changes in the mechanism. So anyway, I mean, this guy said things like, the universe can't produce empty space. So it's Jello with pudding mixed into the Jello. There's no nothing. There's either Jello or pudding. I don't know. I just don't see any point in it. It seems pretty obvious to me that there's empty space, and there's a certain amount of force that's moving through the empty space, and then there's big blobs of matter that we can actually see moving through the empty space. It's quite obvious the blobs of matter aren't just empty space. There's something more to them. But I don't see any reason to doubt the existence of empty space. Anyway, I knew this wasn't gonna. It just gets into a theology discussion, and I don't really want to do that.
That's really a big thing. So, in order to do that, of course, you have to change fundamental assumptions. That the reason the current Big Bang is so popular and Einstein's so popular, is they're using the wrong assumptions, and so because of.
All right, yeah. So this whole idea of assumptions, and the real argument is that I would argue the evidence, unfortunately, doesn't give us a ton of evidence. We don't get to show up at the scene of the crime and have nice bloody footprints and DNA and all kinds of stuff, and we can't just, it's not an easy to deduce truth here. We have little fragments, little tiny pieces of evidence, and there are indications, and there looks like, and there, it's just not as good as it needs to be to do this really very, very high level of confidence thing and say this is the truth. Now, physics is pretending it has all of this evidence, and sort of that's where I could agree with both these guys, that yes, let's do something about the fact that we're being told, almost badgered by an ivory tower pile of elitism that's telling us we're sure we've done all the, don't worry, we've done all the math for you. We know we're right, and we've got the right answers, and we can tell you the whole story of the universe, and we can, dark matter, dark energy, yes, that's most of the thing, and it's the invisible man mostly, and so, we're living basically in the invisible man's comic book, and yeah, just buy it, believe it, because we said so. And all that's kind of bullshit. So we can agree on the enemy, number one, but I'm not in any rush to replace bad ideas like bent space and time dimensions and all this kind of the bullshit, quantum wave bullshit, with another pile of bullshit. I mean, there's no point in replacing bullshit with bullshit. So there's got to be some kind of test where, yes, okay, physics isn't as well evidenced as it should be for their confidence level, but it seems to me that all these cranks, including myself, they seem awful confident for theories I don't think that have been tested very well. They haven't had to answer half the questions I have anyway, and these theories don't seem very complete and even logical. I mean, even superficially logical. So, jump ahead a little bit. It's supposed to work, jumping ahead. I should be able to just click the little jump ahead, please. YouTube. What, am I asking too much? It's probably the stupid ad thing. Right? It's got a
Hello, I am David D. Hilster. I
already did the beginning part. We're not doing beginnings.
The theory may be seen far-fetched, but only requires that we find the vestige of a previous universe floating around in our own. Can't do that. What do they really mean? Well, again, we'll try to discuss what they probably really mean. No, you don't have a universe floating in another universe. The universe is everything.
This is a wrong video.
Okay.
Fucking YouTube. So damn annoying. Well,
hello, I'm David E. Hilster.
What the fuck did it do? How did it jump 2 videos ahead? I didn't do it.
And the way I explain it is G1 particle. And the other blowing of my mind happened to be when he, in July of 2015, saw one of the solutions you can have for the wave-particle duality. And I was just, my mind was blown, but I was kept talking about, well, if there's G1, there's G2, there's particles all the way down.
Right, so particles all the way down, just this whole idea that somehow you can take the mechanism and somehow make it work all the way down. I think the difference between what's happening between electrons and protons is radically different than what's happening between planets and suns, or galaxies and galaxies, or nebulas and nebulas. It's completely different, radically different. There's it's a bunch of forces moving between those things, baseballs, whatever. There's a lot of action on that level, a lot noisier. There's no hoobies living on electrons.
Just, I don't want to know about it. And I remember probably about a year later, maybe, he'd come over and we're hacking the universe with this model. I think it's a very viable model, different from the ether model, but it's, again, totally based on infinity. He came up to me and says,
totally based on infinity. I mean, I don't know how you can base a model on infinity, but whatever. I mean, you still have to explain the mechanics of this universe, so I don't see how infinity is going to help you any. I mean, I don't see how pretending that we're the subatomic universe to some bigger universe, when you have just absolutely no evidence that our universe has any continuity like that. I mean, any at all. It just seems kind of silly. But whatever. Believe what you wish.
Well, G2, and I just stopped him before he even said anything. What? Now you're talking about another level? Well, you have to have it. He says, if there's motion in the universe, and G1, which is light and gravity in our model, and that curves, well, guess what? There's something below it that has to make it curve.
Right. So he doesn't think gravitational lensing happens. I mean, he sort of agrees with the NASA guy who says the lensing images are bogus. So he doesn't really believe light is bent by gravity, I guess. But he does believe that somehow it's bent, I guess, in the two-slit experiment, so therefore we have to come up with some G1 particle that's moving light. So they invent G2. So they invent a second microparticle moving c squared, or that's what they guess at. For an experiment that's just as weak as evidence as all the other experiments. It doesn't prove the existence of photons being moved, by some magical whatever interfering with themselves force. There's no proof there, yet they've assumed that's a valid thing, and therefore we need to create a whole another mechanical mechanism to explain why photons are moving funny, when I think the electrons provide all the reason you need. But anyway, moving on.
It's not so good right now. Physics is really in bad shape.
Yeah, I mean, it truly is, and I think one of the amazing things is that we find, especially with the internet today,
So he says physics is in bad shape. Well, only you think so, pretty much, right? I mean, they're getting away with anything. They can say almost anything now. They can title articles any way they want. We've touched a photon. We've seen electrons. We've videotaped atoms having sex. They can say anything and people buy it. So, I mean, physics isn't really in trouble. The ability for common people to be able to know enough to say that's bullshit, that part's in trouble. There's not going to be any public energy to stop physics from being as preposterous as they choose to be. The talking heads, the elites, can pretty much define physics direction in any direction, and there really won't be anybody to stop them, because nobody else has the credibility to do it.
We keep finding people who have come to the same conclusions. I think it really basically comes down to I always have given my ability, my father's the same way. We always give ourselves the complete ability with an open mind to see anything. The more bizarre it is, actually, I will be attracted to it to take a look at it. But what's really sad is...
Yeah, so I'm just the opposite. I don't think the universe is bizarre. I think it's dirt simple, and it's been missed because everybody's attracted to bizarre. They're attracted to the silly explanation, the aggrandizing explanation, rather than the simple, crappy explanation. And even in describing human beings, I mean, we're clearly just programmed robots. We're born into a circumstance. Clearly, what country you're born in, what state you're born in, what household you're born in makes all the difference, blah, 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 what you're exposed to. We're just freaking programmed robots. We don't do anything truly creative. We just mix the ingredients and, fart a certain smell, and that's it. And instead, everybody wants this more grand notion that I'm connected to some universal knowledge, or I'm a god myself, and I'm just generating godly magnificence. No, I'm just farting. You can fart with your brain, you can fart with your ass, fart with a lot of things.
Some of the most bizarre stuff I read about is from mainstream physics. So right. It's really amazing. I'm going to go to a next quote here, or highlight I made. It says, in the popular press, in the popular press, there's a great fuss about the search for the grand unification of the four forces, which are considered as if they were actual things of the results of things hitting things. Can you explain that a little bit?
Yeah, so he obviously wants to replace the forces with ether. My argument to an ether theory is it has to create the energy somehow. So unless your ether is moving constantly, you're not going to come up with the energy. The Earth moves into the sun. Energy makes that happen. There has to be a force imbalance. Force affects the outcome. It's not just a magical event. And magnets move together because something pushes them together or pushes them apart. It's just not because nothing So some dead ether says so. It has to say so because it has the energy built into it. So you have to explain how the ether manifests something called energy and applies it in the form of force.
Okay, I talk a lot about matter motion terms being used in physics, and those are terms in which you multiply a term for matter times a term for motion. So example, a momentum is P equals mv. So it's mass times velocity, and you get motion. All right, get momentum. Momentum doesn't exist though. And force is the same way. Force equals ma, mass times acceleration. It's a calculation. And so
it's a practical fact of the universe that we've noticed that it takes a certain amount of force to move a certain amount of mass, a certain amount of distance, and a certain amount of time. So yeah, that's just a reality that you have to explain. Why does the matter move? It doesn't move because it says I want to move. Something forces it to move. There's a force involved. You have to account for it.
Forces don't exist. Energy doesn't exist. Momentum doesn't exist. What exists?
Yeah. So what's the point then? This isn't really physics then. If you're going to take away the basic concepts as they're understood about what motion is and what we know causes it and causes changes in it, what's the point? Forces don't exist. It's silly.
Is the matter, okay? That's what exists. And so these are just calculations. They're wonderful. They help us understand matter and motion. But you need to know in an F equals ma equation, you need to know what is colliding with what. That's the key thing. And that's where I essentially had stripped this down to. It's always matter and motion, motion of matter. That's all that the universe is about.
Alright, so I would say exactly the opposite. The matter does absolutely nothing. It wishes to stay exactly where it is and be left the fuck alone, and it'll just sit there. And if the forces don't hit it, it doesn't go anywhere. And that's the truth of it. Everything that moves because some force is pushing it, forcing it to move. An imbalance in force from one side to the other. A change in pressure. Pressure has to be applied or nothing changes. The matter just sits. Matter is inert. It's the force that has all the action, and the matter is just it's just being subjected to it. It's being forced just as we are forced by the exposure we have from the world, from the photons and the information that hits us, and it changes us and it affects us. The forces are doing the same thing. It's all the force. It has nothing to do with this thing. The matter bits are just a byproduct. They just do what the force obligates them to do.
Yeah, that is something, and again, in our model is the same thing. In fact, the title of our book, I believe, somewhere around here, it just says the entire universe as mass and matter in motion, and all those equations.
Right, in motion how? So you're just saying that you're arguing that if this pen gets to be moved and it keeps moving, it just moves because it has magic keep moving in it. It didn't change the pen any. The pen that's sitting here still and the pen that's moving, those aren't different pens. They're exactly the same, no difference. So the one that just keeps moving through space just keeps moving through space, not because I injected it with something. I gave it movement. It didn't acquire the movement because a force went inside of it and keeps it going. It just keeps going because it's once it goes, it just keeps going. It's just magic. It's the go thing. It has go-ness. No, nothing has just go-ness. It has to capture stuff going the way it's going. If it's going somewhere, it's because it captured force going that way. That's what all those flames are doing in the back of the space shuttle. They're imposing force into the shuttle.
All of those things that we write down are useful, but it's really hard. It seems like, you were talking about the cow eyes or the a deer in the headlights sort of look when you talk about all this stuff. One of the things is that when you tell people, really all you have in the universe is matter and it's moving, and it'll collide, that'll happen, but it seems to really
see it really won't though. So that's another misnomer. So we have these, I mean, one of the first things the dissident scientists should be doing is finding fault with the way physics has made such a mess of the vocabulary. Having the words like fundamental particle when they don't really mean fundamental, or elemental when they don't really mean elemental, and certainly using words like matter when matter applies to big giant things full of atoms, and then it applies to atoms, and then it applies to the little bits inside the atom. The electrons and protons and neutrons are also considered atoms, matter. So this whole idea that we don't qualify what is really the actors in the play, and I would argue that what can be, I think, reasonably deduced is that the only actors in the play are the matter bits, that is electrons, protons, the neutron being a combination of an electron and proton, and the force bits. And those are the only players. Everything else is just an arrangement of those matter bits. There is no, and force bits, there's a collection of them. But nothing else is really matter. So when two collections of matter can hit each other, but the little matter bits themselves never do that. The electrons and the protons don't really hit each other because there's a bunch of force between them. They have magnetic rules, and those rules aren't going to really provide options of real contact in the real universe. They're always going to interact with each other based on forces they cause to affect each other. They're going to react to each other's force. Jump ahead a little bit.
Where did that come? And Hawking was asking that question. I remember in his talk, I didn't learn anything except for one thing. He said, Woody Allen had this great quote. He said, "Infinity is a very long time, especially near the end." And that was Woody Allen. I thought that was really great. So
No.
even if you think there's a God that invented the universe, then you have to say, well...
Right, well, it does seem clear that the universe might do something for an infinite amount of time, but it seems clear that it has stages where it does things in the evolutionary sense, like it goes from young to old. Suns clearly do it. Different elements do it. They age and die. They change. They progress. And so I think it's reasonable to say there's certainly something. There's clearly time scales of and practical limitations, I guess, to function in many elements of the universe. So there's no reason to think a lifespan wouldn't be a reality for the systems themselves. Now let's pop ahead a little bit. I'm not going to get through this if I don't get through it.
And what you're doing is just look at it this way. You can pick any portion of the universe, and you're going to have all the laws that Newton came up with. The first law, object keeps going until it hits something. The second law, one thing collides with another, and the third law, the reversal. So that's what we're talking about. So all you're talking about is the changes in kind of motion. You're taking the internal motion and you're converted into external motion. That's all you.
All right, so his argument kind of is that the cells themselves, it's a little bit like the other guy's ether theory, I suppose. It somehow has some energy in it, and the little nucleuses and all the little bits are somehow, they're excreting enough energy to cause effects. But I'd say that still doesn't work for things like gravity. It's clearly not coming from the Earth. It's not coming from the sun, in the sense that we know that in every other case, motion requires you to burn energy. You have to give something away to move somewhere. You have to, the equal but opposite reaction. So the Earth has to lose some energy somewhere if it's going to use some energy to go somewhere. It has to burn it, and burning it means it has to, do the opposite reaction thing. So there's still no explanation for why the magnets are attracting. You can't say it came from inside of the atoms, because we can sort of weigh the atoms. We know what's in them. We know what their content is. So you can't really use this argument that it all came from inside the magnet itself, because the magnet does it for hundreds of years, reliably over and over again, and you can't make the argument that somehow it has this infinite source of energy. Because logically it doesn't.
Do it. It's no big brainer. And if you take out the boundary and the fact that, that you have a microcosm there, it's just the same as Newton's 3 laws. No difference.
Yeah.
But you do have to have one thing, and that is you have to have ether or something.
Right.
You have to have something outside of whatever it is that you study.
Right. No, absolutely.
Exactly. Yes, you have to have pressure on the outside, though. You can't have just nothing. You can't just do it with Jell-O. You have to have Jell-O that somehow creates a change in pressure. Somehow that every little thing in the universe is under pressure from the Jell-O. Then you can make it make sense. But I wouldn't call that an ether. I think you can explain it just like you explain a light bulb. It's a force, and it moves the speed of light, and it comes at a specific density.
In fact, when I was reading your book, I think it's really amazing. This is one of the things. There's this guy called Robert Distinti. If people take a look at my video previous to this, Laura Gardee, who works with fractals.
Yeah, well, this wasn't all that interesting. So now he's going to talk about this word he now likes, called paratheism or something. So you can have many, many theories. So again, the argument that this Distinti guy is making is that our evidence kind of sucks, so you can have more than one explanation because we haven't ruled out the other explanation. So it's like before evolution, or before we had good evidence of any kind of mechanical process that created human beings, the competition was really just about God theories, and you could almost have any kind of God theory because they were all equally made up. So you could just make one up and it'd be just as good as any other one of the wacky theories. But once evolution shows up and answers all the questions and answers them all quite completely, well, then you're sort of out of the game. Then you're done pretending that it's other theories are just as good, because they're not just as good. One answers the question a lot better than the rest.
I was looking at the patterns that she sees, like in galaxies and stuff. There's some interesting things there. She found this guy.
Yeah, well, whatever. She's a little bit wacky too. Ken Wheeler fan, she is. But yeah, see, fractals is just wishful thinking. People just want to. It's a romantic notion. Oh, it's all related and it's all this and it's just bullshit.
Right. And George Coyne also really emphasized this, that matter is an abstraction.
Yeah.
And I think that is really good. And all we have is examples of matter. It's like fruit's an abstraction.
I know, but look, even if matter is even if the littlest bits, the electron and the proton, were just made out of whatever fake thing would be, some kind of fake thing. It's clearly not nothing. It's clearly a something, but it's just like little sparky stuff or something. And photons were just little pieces of spark. It doesn't matter. Okay, it doesn't matter to the question of matter. We clearly know the distinction between nothing and something. You can see the difference. The empty space, and you put something in it, you can see the difference. Oh yeah, there's a something. That's mostly nothing. This is mostly something. I just don't see any point in playing games of semantics and saying, well, that's turned into nothing. We kind of know we've quantized so much of its function. We've narrowed we've made distinctions between these different things in terms of reliable statements about how they function. they'll do the same thing every time. I mean, every time I do a certain thing with this pen, it doesn't do something magical. It does certain things, and it can't do other things. It can't write by itself. It can't do a lot of things. So we know what it is when we say the word matter. So this idea of just saying, oh, it's a fake word, it's just, I don't think that's useful.
And we have examples of fruit, apples, oranges, and so on, but there's no such thing as fruit, and there's no such thing as matter. So that's another reason that nobody's going to ever find.
Yeah, so whatever that means. There's no such thing as matter. There's no such thing as proof. Of course, there's evidence beyond reasonable challenge. You present an evidence case, and the evidence is just overwhelming, and there's no way you can find a fault with it. You can't find a fault with how much it explains the world that exists, and you can't find any reason to cast doubt on it. Well, that's a proof, in my opinion. And something far less than that, in my opinion, is all we have to do is go beyond reasonable challenge. A theory that is beyond reasonable challenge, that's pretty much a proof. It just is. I mean, if the evidence is strong, you have to give it credit. To pretend that strong evidence is the same as weak evidence is idiotic. They're not the same thing.
Second, and in so-called empty space, 300 million. So obviously, the speed of light is not constant. It depends on where it is traveling. And one of the things we had noted when we studied the gravitational redshift is that the speed of light actually increases as you go away from the Earth. And only a tiny amount, but it does increase. And so that's why you get longer wavelengths as light goes away.
So I don't know how that would even work. How changing the speed changes the wavelength. Because each one of the particles is still going to be the same distance from each other. So, I mean, I don't know how you change the how does one photon go faster and the other photon doesn't? That doesn't really make any sense. They'd all go through the same place that would make them go faster. So as they got further away, they'd all go further away faster at the same rate. So how could you change the frequency? Just saying, that doesn't make much sense. But again, challenging things that the constancy of the speed of light is so reliable. I mean, I don't know why dissidents waste their time attacking that, or questioning it. I mean, it's the speed of force is just you can count on it.
And that has been called by the relativists to such things as time dilation or whatever. And of course, that's kind of silly. If time doesn't dilate, because time is motion, only things can dilate. So, yeah, light is going to be different. The speed of sound has changes depending on temperature.
Yeah, well, again, yes, time dilation there's alternative explanations that I think are viable for why velocity changes the metabolism of matter. So, yes, and it's probably just that simple. And it's not really a physical effect that has anything to do with most common physical interactions, so, but whatever.
Pressure and so on. And so we have not found any constants. It's sort of like pi is not a constant. And that's the way the infinite universe occurs. Pi has an infinite number of characters after it and digits. And
So again, you can just say that kind of stuff, but I don't think it's what it comes down to. I think what pi comes down to is the fact that you have to be able to go billions of levels smaller to get to the square circle, to get to the original circle that creates a circle. A circle is really just an at least billion icon, hexagon with a zillion little surfaces. So a circle is never really a circle, and that's the problem. There's a plank to it, but you have to go all the way down to the plank to get to it. So pi has a resolution, but its resolution is going to be 10 to the minus 42 or something. It's going to be a very, very, very small number. I mean, lots of zeros, 42 of them.
We have is essentially that for everything. Now light is quite precise, so as it travels through only ether, which we, empty, so-called empty space. That is true, and the changes are slight, and but nevertheless, we can't expect to be constant.
Now you did mention stuff.
One thing I also wanted to
Go
point
ahead.
out.
Go ahead.
Okay, what I wanted to point it out. Remember this whole Big Bang mess that we got.
I meant 10 to the minus 42 zeros, not 42 zeros.
Into is based on Einstein and his idea that what I call untired light theory, and I haven't heard anybody else call it that. But what he essentially is saying is that even ether, or as a particle traveling from point A to point B, can do so without losing energy. Now that defies the second law of thermodynamics. Remember what the second law of thermodynamics says.
Yes, I'm glad you noticed that. Yes, this idea that you can move stuff without accounting for where the movement came from, right? So if the objects aren't burning any fuel and they're accelerating, then you have to assume there's a force accelerating them. You have to explain where it came from. Where did the energy come from?
You lose energy through the interaction with the environment. And it's sort of like this. If you're trying to move electricity from New York to San Francisco, what's going to happen? Is it going to be 100% transmittable?
No, absolutely.
Have you ever stood under a transmission tower? What do you hear?
A lot of crackling.
It's buzzing away, right? Yeah, and so that's what happened, and so you misinterpret.
So I guess in his theory, photons are losing energy, because they're being transmitted from one place to another, which is, I think, nonsense. But like to me, the rule is more illustrated in the idea of if you make something like a track runner running around the curve on a track, or a car going around a track, and all it has is its engine providing its movement. And so when it turns, it's got to use its own energy to make the turn, and it's got to lose energy through friction to make the turn, and there's no force from the outside pushing it in, so it has to lose energy, where the Earth clearly is being pushed in by a force, so it doesn't have to use its own velocity, so it doesn't slow down to go in its circle. It can maintain its velocity because it's getting pushed by an external force.
Interpretation of the Hubble law is exactly that. It's essentially saying that light can travel without losing energy, and there's no way that could possibly happen. And that's
so he says it kind of emphatic. There's no way that's possible, and it's like, well, sure it is. So I don't see any problem. Photons, that's the way they work. They just go through empty space at the speed of light, and it isn't until you put something in their way that you change their speed. They don't slow down. They don't run out of gas. They're perpetually in motion. They're perpetually hostile to the nothing, and they're moving the speed of light to escape it, so to speak. They're the first, what you could call, negative-positive reaction. It's the first repulsion. The photon is the first repulsion. It hates nothing, and it's trying to escape it at the speed of light.
In infinite universe theory, we don't have an expanding universe.
Well, you took my question, because that was exactly my follow-up question, but you got to it before. Like minds think the same. So there you go. I was going to wait. That was my
There you go.
Good. Hey, I didn't even have to ask you. In fact, I'm just going to turn it over to you and turn off my mic here. So no, I'm just kidding. No, absolutely. When you were talking about that, I said, "This is what about the redshift? This is like goes against all of that." So basically, what you're saying is that anything that's
right. But see, these guys don't provide any reasoning to why they think redshift isn't real. That they've got it wrong, that they figured it out wrong. They really don't explain that in any kind of detail. So you do have to account for it. I don't care one way or the other. I'm not worried about whether the universe is expanding or contracting. It just doesn't seem to me to make any difference. It seems obvious that if it was expanding, as an explosion expands, but they claim it's expanding in this weird way where somehow the cosmic background radiation didn't expand with the rest of the universe's expansion, that somehow it stayed, with whatever was expanding. It wasn't expanding between photons or expanding between electrons or expanding between protons and neutrons. So this expansion somehow happens between atoms, not inside of atoms. So the whole thing doesn't make much sense. But clearly, if material objects, once they're moving, move at different vectors, it's going to appear like they're moving away from each other just because the vectors move away. So if something knocked the Earth and the Moon in some new direction and the two were traveling in non-parallel lines, it would look like the Moon's leaving us, when it's not really. It's just going a different vector. It's not deliberately moving away. But whether or not it would look that way from redshift is a whole another argument. I mean, there's no understanding of what light does at high speeds when things are moving perpendicular to you. Whether the light is redshifted or not, we don't know, because we can't see anything moving fast enough to know.
Moving light or whatever, you can't have, it's not perfectly, you can't it's going to lose some of its motion. If it's going,
let me explain that a little bit. And I've emphasized this in the last book. I didn't in previous books, but what we're talking about is waves. Now, to produce a second wave after, say you have water wave and it's moving along, and now it's going to produce a second one. In a perfect world, that second one is identical to the first one. But that's not how our world works. It loses some of the motion. So the second wave is not the same as the first wave. And what we see there is a lengthening in the wavelength, and that's what the redshift is all about. And so this is simple. This is not complicated. That's why I think people should read Infinite Universe Theory. It's easy.
Right, so he's saying a photon's being created by something waving, like going up and down, like you drop a pea into the water, and the water keeps vibrating up and down at the location where the pea went in, and it keeps making new waves. And somehow photons coming a billion years from some star somewhere are somehow the waves off of a single little electron bouncing or something. I don't know. Sounds like horseshit. Jump ahead.
Becomes decelerated. That's Newton's second law. Remember, one thing colliding with another. This is something that I have not seen anyone else talk about. And it's obvious. When you study gravitation, it always involves an acceleration. Acceleration by what? Einstein says that gravity is what, a bent space or something. And others talk about attraction, which there is no law. We have an attraction law. His three laws don't talk about that. And essentially, what you got to do is keep your eye on the ball, and that is what is colliding with what. Remember, that's where we got onto this boat, is matter in motion.
Right.
And okay, so then when these particles collide, what do they do?
So I think he's saying now the ether's particles, and somehow they're waving. I don't know. So the ether now has become some kind of particle. So that's a little bit, messy. But he's quite right about the fact that the acceleration is what really is creating gravity. So, I mean, I do plan on doing a video on that movie Interstellar, because it was so bad. But clearly people have this idea that because Einstein created a relationship between all accelerations, that somehow just being in gravity means you're automatically accelerating at whatever level of gravity you're in, and that you have some sort of so the real key thing is the time dilation happens because of motion, velocity. And as I've pointed out, if you're moving around the surface of the Earth just going straight, right, that's just, you can just straighten that curved line and say that's how far a distance you traveled in a certain amount of time. But if you really think about what's probably happening when you're in gravity, is you're probably bouncing up and down. I mean, theoretically, as much of my mass is going down at 10 meters per second as it's going up 10 meters per second from the rebound from the Earth. The pressure increase the Earth creates, pushing me back up. So in reality, my atomic structure is essentially 1 minute some atoms going up, the next minute the atom goes down, the next minute the atom goes up. So I'm essentially bouncing in the gravity. So you can see that this bouncing, okay, if I was to take that line and then stretch it out, I moved a hell of a lot further than the distance the Earth rotated. And the same is true for the satellites. And so the weird thing is, okay, this is the Einstein thing that's kind of people don't really realize, is our clocks are the slow ones here on Earth. That's the fact. Because we're in the higher gravity, which means we're bouncing at a faster rate because it's more gravity. And the satellites are in the weaker gravity, so they're bouncing slower. So they don't travel as much. Even though their speed is higher than our speed on Earth, it doesn't matter because they're not bouncing as much. So they're not really traveling as far in terms of real distance. So their true velocity isn't faster than our velocity. We are the ones moving faster. So that's the catch with gravity. But clearly gravity is associated with acceleration. You actually have to move something. The mass has to move or there won't be the creation of gravity. So we're not really creating gravity because we're not really moving. You know, we bounce. We give away our movement. We take as much as we give to gravity, so to speak. So in a sense, we don't have any.
They're slower.
Right.
They hang around. And that's why ether is then trained around the Earth, and that is why the Michelson-Morley experiment was not able to detect ether. Why? Because it was entrained.
Right.
They were looking for a fixed ether through which the Earth was moving, and the ether was carried along with the Earth. That's the key.
Right.
And so, anyway, there's more details in that.
I play that again. I couldn't quite hear it. Unfortunately, I have to keep the volume down so it doesn't get the feedback problem.
The gravity is a bent space or something, and others talk about attraction, which there is no often have an attraction law. His three laws don't talk about that. And essentially, what you got to do is keep your eye on the ball, and that is what is colliding with what. Remember, that's where we got onto this boat, is matter in motion.
Right.
And okay, so then when these particles collide, what do? They're slower.
Right.
They hang around, and that's why ether is then trained around the Earth, and that is why the Michelson-Morley experiment was not able to detect ether. Why? Because it was entrained.
Right.
They were looking for a fixed ether through which the Earth was moving, and the ether was carried along with the Earth. That's the key.
I don't think that really explains it, but it clearly not going to be able to explain why you wouldn't have ether drag from particles flying through space. So again, it really doesn't explain why things don't lose their velocity when you shoot them into space. They should lose velocity if that's how the ether is working. And so he has to sort of explain that, but I don't think he will, so no point.
Have particles banging around, and they push things around. It's all local. I totally disagree with those who, like Duncan Shaw and so on, who actually say like Lesage did, that these particles come from a long distance and so on. And I'm pretty sure that you can say the lack of aberration essentially eliminates that particular possibility. And so that's why I like the local effect. It's just the pressure effect. The pressure of ether is greater further away than here it is to Earth. So,
right,
it is, so it's sort of the reverse of the atmosphere.
Right.
Whatever. I don't think that really explains photons at all, so whatever. They're clearly a corpuscle.
Also, I want to get to part of your book as well. There's so much in it, but I wanted to give you time on it because even though it's different from my father and I's theory, you were talking about I remember you had mentioned to me that you were hypothesizing that the ether was more like sort of a flying disc, sort of right. It was sort of like two hubcaps put together that are really sort of rounded. And there was a reason for that because of the types of waves transmission. I think this is the first time you really talked about this in real detail. Is that true?
Yeah, I think my other books didn't get into that. And for one thing, the vortex model that I use is very similar to what we see throughout the solar system's vortex and Milky Way galaxy. And everything seems to want to revolve around everything else.
Right. So now we're back to Ken Wheeler kind of stuff, that somehow there's all this energy vortexing around magnets, and everything's got all of this motiony stuff, and it's all happening with this stuff that we can't measure and we can't see, and you can only see it with a ferrocell or something, and you still can't see it moving even when it's a ferrocell. That's the kind of stuff where I say you got to have some evidence, and it doesn't seem to me they have any evidence of these vortexes creating attraction and repulsion, or any evidence of where they're flowing to and how come we can't detect them. If they can move matter, we should be able to make them move a piece of confetti. If there's something vortexing, we should be able to throw something in it and watch it get moved by the vortex. Can't do any of that.
And that's how the universe is put together. And so I said, okay, well, let's just take it down a step and have ether particles be that. And that would explain one of the big problems with ether theory, is that it has mostly T waves. Now, T waves are transverse waves. They go sideways. And then, of course, there's L waves that go back and forth. And L waves are common in such things as sound in the atmosphere. Mm-hmm. Now, the particles that are moving there are nitrogen, the molecules, and so on. They're almost round. And so they bang together, and they can do L waves back and forth. And the problem...
Yeah, again, the idea that they're actually banging into each other is kind of suspect in a sense, but whatever. Clearly, the forces of the electrons are repulsing each other, and that's why atoms bounce, but they don't really bounce into each other. But whatever. Clearly, there's no, you can say there's a medium in space, but I'm just saying, why can't we detect it would be the simple question. If it's there, why can't we detect it?
But, expansion in his first paper, which made it very popular because people wanted to hear about that.
Yeah, I think.
Wrong.
Yeah. Oh, I think people would be surprised to find that a lot of these people who we now consider in mainstream science, people in mainstream science consider to be very, solid in their assumptions, if they had them. Most of them they don't, because if they were to say them, they conflict so much, which already happens. But when we look back at it, that the actual people involved with these things would be as skeptical as we are today, because we do our best to come up with models and make things better. But we know that in the future things are going to be how do you say, improved quite a lot about what we're doing, and that Einstein and all those other people, if you talk to them.
So again, I would argue that there's, I think, just as many flaws in these replacement theories as there is in the theory they're replacing. So I don't see this prospect of this fixing anything. Clearly, conventional science shouldn't be as obnoxious and arrogant as it is. But the naysayers seem also excessively bold in their assertions, and some of them are quite, extraordinary claims, less than ordinary evidence.
Probably one-on-one, they go, yeah, this stuff is good, but this could all be wrong. So we have this idyllic idea of how all this science works. So I remember talking with you about the book that you did with Steve Pitts. And I had said to you this phrase, and I was just curious. I said, you know, Glenn, you should extract the neo-mechanical part, which is really, I guess, more of infinity. And I wanted to ask you about that, being a student of your work. How do you see it now? Because at the time, you know, there was the cycle theory that was part of it. There was neo-mechanics, and then the infinity part. How do you see the neo-mechanics and infinity today in your infinite universe theory? How would you describe those two? Because I know you've talked about neo-mechanics that's my question. It's my own personal question.
Oh, yeah, right. Well, remember that mechanics is a finite theory, and neo-mechanics is an infinite theory. So what it says is that, for example, the number of causes for any effect is infinite. Now, with mechanics, with Newton and so on, you'd say, no, it's finite. We can number them, you know, A, B, C, D, or whatever. And turns out you can't.
Well, I mean, that's kind of a silly thought experiment even. I mean, obviously the causes for everything have to go all the way back to the first cause, because that's where that was the cause. You can't separate it from the thing that caused the motion of everything. So clearly, you know, this argument doesn't really go anywhere. Like, say if the universe was oscillating, it exploded and it contracted and exploded and contracted, all the causes would be, in a way, directed all the way back to the initial explosion, in a sense. So you couldn't ever escape the first cause being the cause, because it creates the first, you know, every vector is decided by the first initial vector. You can't escape that. So, but it's kind of, in my opinion, kind of a useless part of physics. There's no point in fiddling with first causes. Just isn't even, there's no fruit to pick in that subject, and I don't even, you know, I don't know why you'd be hungry for it.
You know, the way scientific, the flow of science goes at a big scale, and I think your work, you say it, but it's absolutely true. This is a huge paradigm shift, and you know, I had always told you that someone come along and use your infinite theory, universe theory, to make a model. My dad or two of us.
Yeah, right. A model is completely different than his, and I guess he doesn't find that irritating as fuck. But I would, you know, certainly. Yeah, I used your idea to make a completely different idea that believes in a completely different premise. Thanks. Appreciate it.
Right or wrong, but I will tell you, you know, these are the beginnings of that shift, and I really do think that we're at a time where people are going to more and more get this, because there's just so much. I think the reason I had such a tsunami.
Yeah, it's all truth or bullshit, frankly. The object is to try to examine the evidence. The evidence wasn't examined enough in the process of establishing these truths. The bench space evidence, not enough. The time dilation evidence, not enough to assume more than there's a relationship between velocity and metabolism breaking, or clocks breaking. That's all we have evidence of, is that clocks don't work when you move them too fast. No evidence that there's any frames or any other kind of crap. So it's just all these, you know, all these assumptions and exaggerations of the evidence is the problem. And re-examining the evidence, I think, will lead to something, a more mechanically rational description of the causes. And I think I've done that, frankly. So you don't have to, because I did it already. I have the right answer. You can keep looking for the right answer, but I think I am the one that has it.
and you can never go back. And that's, applause to you. And, thank you so much for taking the time. And of course,
Thank you so much.
of course, I'm going to be working with you. And audience, I think we're going to do it. I think he's going to get on YouTube and start his channel, because I will be watching everything he comes. I don't care. I know this stuff I know this stuff a lot. It's still listening to Glenn talk about it will be just great. The other thing too is, I'm going to tell you, Glenn, that my dad's working on his model, which again is a different model, but
yeah, it's a different model that doesn't deal with the 300-year-old problems with those kind of models. You have to deal with the objections and the consequences. I haven't seen any of that. Just some vague idea that it sort of looks like this. And sort of isn't good enough. But anyway, enough. Sorry, not, just feared it was worth some conversation. But yeah, I'm just totally unconvinced that a conversation about how old the universe is essential to understanding the physics of the universe. I just don't think it's productive. But whatever. Just me. So, till the next time and such.